Hello everyone, welcome to my new video. In today's video, we are going to speak about inequalities and its basic properties. Okay, so let's get started. Okay, first of all, how do we spot the inequality? Okay, it's very simple. Okay, so whenever you see any expression which has two mathematical statements and in between you see less than or greater than sign, then it means it is an inequality. Okay, for example, x is less than 7. Okay, this is an inequality. Why? Because this side you have mathematical statement, right side you have mathematical statement, in between you have less than sign. Okay, if it is greater than, then obviously it is again the inequality. Okay, so in this session we are going to discuss some of its properties. Okay, so let's say that uh, x let's say that a is or x is less than equal to b. Okay, this is the given inequality. What does it mean? Okay, now see here, x is less than equal to b. It means either x is less than b or x is equal to b. Okay, I hope you know this. Or if I have x greater than equal to a, then what does it mean? It means either x is greater than a or x is equal to a. Okay, now if you are given with an inequality, let's say that you are given with this inequality, a is less than b. This is the given inequality. Now if you increase or decrease the value on the values on the either side of this less than, then it won't affect the sign of this inequality. What does it mean? What I'm saying is that if you add or subtract, okay, if you add or subtract any constant or any number to either side of inequality, then the sign of inequality, it won't be affected. Okay, let's see here. Let's say here 10 is less than 20, right? We know it. It defines math, right? So here, if you add plus 5 to both sides, okay? So here you will be having 15, here 25. Now 15 is also less than 25. See here, the sign remains same, okay? Similar is the case when you subtract. Here, again, same example, 10 is less than 20. This time, I'm going to subtract 5 from both the sides. Okay, 10 minus 5, here I will get 5. Here, 20 minus 5, 15. So again, less. You can see if you increase or decrease the values on the either side of inequalities by some constant, then it won't affect the sign of inequality, or the sign of inequality won't get inverted. Okay, I hope you got my point. Okay, now let's come to the next point here. If you have, let's say I have two inequalities here. First is a is less than b, and here I have another one, c is less than d. Okay, now see here, in this inequality, a is having smaller value and b is having bigger value. Same here, in this inequality, c is having smaller value, d is having bigger value. So if I add these smaller values, then their sum is always going to be less than the sum of b and t. Okay, It's obvious. Now see here, if you add two smaller values, then the sum is always going to be less than the sum of the bigger values. It's obvious thing. Okay, so you must know this. Okay, the other way to write this is that, what can I do here? If I bring d to this side, then it can be a minus d. And if I send this c to other side, it will be b minus c. Okay, so this is also the result that you can derive or deduce from here, right? This is simple. Okay, now come to the next one. The next one says that if your a is, let's say that we have this given inequality, a is less than b. Okay, a is less than b, and here a and b must be the positive real number. So here I am using this 0. Okay, so from here I can say that a is less than b. Okay, now what happened is that if I want to multiply, now here I want to see that if I multiply the either sides of inequality by some number, then how it's going to affect the sign of inequality, right? So for this, it says that k a kb, and here ka is greater than kb for all k greater than 0, and here k less than 0. We are going to see it. What does it mean? Okay, let's say that I have two, sorry, let's say that, let's see this case here. I'm taking the case of 10 and 50. Okay, so obviously 10 is less than 50. Okay, now if I multiply both sides of this inequality by 5, okay, let's say here 5, okay, and here 50 times 5. Okay, now 10 times 5 is 50, and here 50 times 5 is 250. Okay, now you see here, so what sign will come here? Obviously, this is less. So if you look at the sign remains same when you multiplied the either side of inequality by some number, right? Then it didn't affect it didn't uh, alter the sign of your inequality, right? Provided that the number that you have multiplied with, it must be positive number, it must be greater than 0. Okay, so here I can say that here, from here I can say that if this is the given inequality and you multiply both sides with k, then this side is going to be kb, and if your k is greater than 0, it means for all k positive numbers, then it's not going to affect the sign. Okay, this is what it says, right? Now move to the other case. Here again we'll take the same example, 10 and 50. Okay, so obviously 10 is less than 50. Okay, now this time what we are going to do, we are going to multiply either side with negative real number. Okay, so let's say here 10 multiply by minus 5, and here with same minus 5. Okay, now here I have 50, and here I have, sorry, minus 50, here minus 250. Okay, now look at both the values, then it's easy to figure out this is greater than this. Now look at the sign. Now the sign has inverted, right? So what does it mean? From here we can say that if A is less than B, then Ka should be greater than Kb for all k less than 0. Okay, so this is important result. This is important result. Okay, the same goes for division too. When instead of multiplication you divide. Okay, why? Because division is also a kind of multiplication. Okay, see here what I'm trying to say. What I'm trying to say here. Let's say that here again, I'm taking the same example here, 10, 50. Obviously, it is less than 50. Okay, this time, if I divide either sides by, let's say, 1 by 5. Okay, so what's going to happen? So 10 divide. So division is also a kind of multiplication, means that 1 by 5, right? And here, divide by 5. Okay, now this is going to be 2 and this is going to be 10. Now, obviously, 2 is less than 10. Now, look at the signs. So, it didn't affect the sign, which means that, again, the meaning is the same. If A is less than B, then your Ka is less than Kb, provided that your K must be greater than 0, right? And again, let's take the case of division with a negative number. Again, 10 here, 50 here. So here less than. So this time we are going to divide by minus 1 by 5 or divide by minus 5. So it's the same. Minus 1 by 5 and here 50 divide by 5. Okay, so from here what we will get, minus 2, from here minus 10. Now you look at both the values, so obviously which one, this one is greater. So look at the sign has inverted. Okay, so this is very important result. Okay, so I hope you understand this. All right, now let's talk about a few more things here. Now come to the next property. The next is your transitive property. Okay, so what does your transitive property says? Transitive property says that if your A is less than B, right, and and your B is less than C. What does it mean? Now, if I combine both, then I can write it like this. I hope you agree with me. It means A is less than B and B is less than C. Okay, so if this happens, then you can establish the relationship between A and C. Okay, now look at this inequality. From here I can clearly say that, A is going to be less than C, right? Okay, so here you can establish relation between A and C. Okay, so you can also see it through number line. Okay, let's say that here I have a number line and it says that A is less than B. So here I have B, so A must be here, and B is less than C, and B is less than C means C is here. So clearly we can establish relationship between A and C, meaning that A is less than C. Okay, but here see, if you have A less than B and here it says B is greater than C, now there is a problem. Now you cannot establish relationship between A and C. Okay, let's see it on the number line. You can visualize it. Okay, so a is less than b. If b is here, means a is here, and b is greater than c. Now, where is c? Okay, so we see here, c is less than b. Now, c can come either here or either here, right? So now it's so hard. It's not possible to deduce the relationship between a and c. So here you cannot you cannot relate relate a and c. I hope you understand my point, right? Then this is also known as, this thing is also known as your transitive property, right? This is also known as your transitive property. This is very important too. Okay, now let's go to the next one. Now, let's say that we have this inequality, a is less than b, provided that a and b are are positive real numbers. Means that here I can say this. Okay, so it means that a and b are positive real numbers, and a is less than b. Okay, so now here, from here I can say that uh, if I raise these bases on the either side of inequality to to some power, and that power must be same on both the sides, then how it's going to affect the inequality, right? So let's see. So here, if I raise a to the power, or if I raise this base a to the exponent r, and this b to the exponent r, and is if this r is greater than 0, then the sign of inequality will remain the same. Okay, so again, what I'm saying, please take a note. I'm given with this inequality. So what I did, I raised the basis on the either side of inequality to some exponent r. So if my exponent to which I raised this basis to, if that exponent, the value of that exponent is greater than 0, is positive, then the sign of inequality won't get affected. Okay, but if this value is going to be less than 0, then it is going to affect the sign of inequality. Okay, so we will do it step by step. Okay, let's take this case first. Let's say again 10, and here 20. Okay, now here 10 obviously less than 20. Okay, now do one thing. Now uh, raise raise the basis on both sides to the power 2. Okay, 2. Okay, now see here, we have higher base. Okay, and we raised both the bases to same exponent, so the higher base, this base is higher, so overall value will be higher. This base is smaller compared to this, so the overall value will be smaller. So see here, again the sign will remain the same, provided that the value of exponent to which you have raised this basis to, it must be positive. Okay, so see here, it's going to be 100, 400. Clearly the sign of inequality, it is not affected, right? Now take other case. The other case says that if this is the inequality, a is less than b, so if your r is, if you raise the basis on the either side to the exponent r, and provided that the r is negative, then there is a problem. The sign of inequality will get inverted. Okay, so this is very important result. This is very important result. Okay, let's try to understand it with the example. Okay, now again we'll take the same example. Okay, here we have 10, here we have 20. Obviously 10 is less than 20. Okay, now I will raise both the bases to the power minus 2. 20 minus 2. So what does it mean? So this can be written as 1 by 10 square, and this can be written as 1 by 20 square. Now, if you see here, in denominator, I have higher base, means that in denominator, I'm going to get the higher value, but overall value, it will be smaller, right? Here in denominator, I have smaller base, right? And the overall value is going to be higher than the value on the other side. So here, clearly, what would happen? This is going to be greater. Now you can see the signs are inverted. Okay, so when you raise either side of basis, okay, to some exponent, and the value of exponent is negative, then the sign of inequality will get inverted. Simple, right? Okay, now there is one more case that you have to observe. What is that? Now, it's also possible if this is given inequality, a is less than b, and here a and b lies between 0 and 1. Now, this thing will take you back to exponential functions, right? Because we have done this thing there too. Okay, so in this case, what would happen? Let's say that, okay, now here I'm writing 3 here and I'm writing 3 here. Okay, so my bases are same. Okay, so here if I raise this base to the exponent 10, and if I raise this base to the exponent 5, then which will give me the higher value? Obviously this one, so I will say this one. Right, now take this case. Now take 0.3 both sides. Now raise this base to the power 10 and raise this base to the power 5. Now, which is going to give you the higher value? So, obviously, this value is higher, right? So, when you deal with the inequality and the value here, let's say the value of a and b, it lies between 0 and 1, then you have to deal with this case. Okay, obviously, why? Because as you will multiply 0.3 10 times, then this value is going to be smaller, right? Because here you have decimal. Okay, so it's obvious. Okay, so this value is going to be higher and this value is going to be lower. Okay, so that is what this property says. Okay, not property, but it is a special case. Okay, just don't forget it. Also, one more thing that I would like to discuss here is I think in the last session I forgot this thing. Okay, in the last session we spoke about the intervals, and I have lost one thing that day, that we said that that day we discussed about open intervals, closed open, open closed, right? Now you can get one case too where you are given the interval, right? You are given the interval and they will ask you to exclude some points or some values from that interval. Let's say that uh, here, this is my number line. So here, let's say I'm given with this interval 2 to 7. Okay, and I'm asked to find the value of x that I'm asked to find the values of x, but they are telling me you can take any value of x. X can lie in this interval, but it should not take the values 3 and 4. Okay, so what I'm trying to say here is that x belongs to 2 to 7, but x is not equal to 3 and x is not equal to 4. Okay, so if that's the case, where or x is not equal to 5. If that's the case, where you have to exclude some points or some numbers from your interval, then how should you go ahead with? Now see here, here I cannot write it like this. Here, if I have 2 here, if I have 7 here, and here 3, here 3, here 5, right? And I don't have to take these values, right? These values, I don't have to take these values. So here, 3 and 5. Okay, so in that case, I cannot write it like this. Most of you may be thinking that we can go with this. X belongs to 2 to 7 minus 3 to 5. Now, this is not the right way, right? I mean, this thing doesn't make any sense. Okay, now see here, when you have to exclude some points from the interval, okay, then you have to use the set form. Okay, set builder form or the roster form. For example, if I have to exclude these 2 points, right, from this interval, so here I have to say interval, open interval, 2 to 7 minus 3 and here 5. Okay, understand? So it's going to be, so what I will get from here, uh, so here it's going to be 2 to 3 union 3, here 4, right? Union 3 to 5, union 3 to 5, yes. Again, union 5 to 7. Okay, I hope you understand. See here, from 2 to 3, but 2 and 3 are not included, right? Then 3 to 5, 3 to 5. 4 is included, yes. 4 is included, yes. 3 to 5, and here 5 to 7, yes, correct. So remember that when you have to, let's say that here this is my number line. Okay, here the interval is from minus 3 to 4, minus 3 to 4, and you don't have to take two values. Those values are minus 1 and 2. Okay, so then how you are going to represent it? Then you can say x belongs to open interval minus 3 to 4 minus, and here in this set form here you can mention minus 1, 2. I hope this is clear. Understand? Here you cannot use open interval because that means something different. Okay, so I hope it makes sense, right? We are going to use it more often when we have to omit some values from the given interval. Then we have to make use of this set builder or roster form. Okay, so this is when we have to exclude some particular values from your interval. Okay, Then there are two more things, two more results that I want you to remember, but we will work on its proof in the coming times. Okay, and what are those? Uh, a plus 1 by a, it is always going to be greater than equal to 2 for all a greater than 0. Okay, and a plus 1 by a is less than equal to minus 2 for all a less than 0. Okay, so what does it mean? It means the sum of a number and its reciprocal, it's always going to be greater than equal to 2 if your number is greater than 0. Okay, and the sum of a number and its reciprocal, it's always going to be less than equal to minus 2 if your a is negative. Okay, you will get here the minimum value you will get is at a equal to 1, and here the minimum value you will get when your a is minus 1. But don't worry, just remember these two results. I will do the proof in the coming times. Okay, so that's all for today, and I will see you next time. Thank you very much. Bye bye.